right, welcome back, everyone. Today we're going to be taking a deep dive into some really cool research from DeepSeek AI. They've been doing some really interesting work on LLMs, specifically making them better at reasoning.
Yeah.
And get this, they're doing it without using massive amounts of labeled data.
It's really impressive stuff.
Their paper, it's called DeepSeek R1.pdf.
Right.
It shows some fascinating insights into how these models are learning, and we're talking about AI that has like aha moments.
Yeah, like little breakthroughs.
Yeah, self-correction, reflection,
Right.
just like we do when we're tackling a tough problem.
Exactly. It's a pretty big departure from how things are usually done.
Right.
Most LLMs today, they rely on this thing called supervised fine-tuning,
Right.
which basically means they need a ton of examples to learn from.
Yeah, that sounds really resource intensive.
It is incredibly resource intensive, and that's one of the things that DeepSeek is trying to get around. And they're not shying away from the competition either.
Yeah.
They're benchmarking their work against OpenAI's O1 series models.
Okay, so that's a high bar.
Yeah, you could say that.
So let's jump right into it and talk about DeepSeek R10.
Okay.
This is their self-taught model, and what I find fascinating is it learns purely through reinforcement learning,
Right.
which means no hand-holding, no labeled data.
Exactly. It figures things out on its own.
So for those of us who aren't like AI experts, how does that even work? Is it like teaching a dog tricks or something?
Yeah, that's a good analogy. So in reinforcement learning, you basically set up a system of rewards.
Okay.
So if the model does something that gets it closer to the desired outcome, it gets a reward, and over time it learns which actions lead to those rewards.
So it's all about incentives.
Yeah, you could say that. And DeepSeek's system is really clever because they reward DeepSeek R10 for both accuracy, meaning getting the right answer,
Okay.
and for following a specific format for its thinking steps.
So it's not just about getting the answer, it's about showing its work.
Exactly. Like we had to, back in school,
I remember those days, and the results are impressive, right?
they're really something. On the AME 2024 math exam, for example, DeepSeek R10 went from a 15.6% accuracy rate to a whopping 71%
Whoa.
just by learning through this reward system.
That is a massive jump.
It is, and to put that in perspective, that's getting close to the level of OpenAI's O10912 model.
Wow, so we're talking about a model teaching itself to solve complex math problems without any direct instruction.
It's amazing, right?
It really is. And here's what I find even more mind-blowing. The paper mentions that as training progressed, DeepSeek R10 actually started spending more time thinking before giving an answer, generating sometimes hundreds or even thousands of reasoning tokens.
Yeah, that's right.
Like it's really pondering these
And
problems.
it's like it's actually trying to understand the problem before spitting out an answer.
That's incredible. And this wasn't something that they programmed into the model.
No.
This emerged naturally through the learning process.
Yeah, it's one of those emergent properties that you often see in complex systems, and it's actually a lot like how humans learn.
Mm-hmm.
The tougher the problem, the more we tend to think about it before we try to answer it.
Right. It's like going from just scribbling down an answer to like carefully planning out each step.
Exactly. And the paper actually gives a specific example of this in Table 3, where the model reevaluates its approach in the middle of solving a problem.
Oh, wow.
Yeah. So it realizes it's going down the wrong path, and it course corrects.
So it's like it has this aha moment, like, wait a minute, I'm doing this all wrong. Let me go back and try a different approach.
Exactly. It's an incredible example of emergent intelligence. And, it's the kind of behavior that wasn't explicitly programmed, but arose purely through the power of reinforcement learning.
That is so cool. Now, DeepSeek R10 wasn't perfect, though, right?
Well, no model is perfect.
True.
It did have some issues with readability, and sometimes it would mix up different languages in its outputs.
Ah, I see.
So that's what led them to develop DeepSeek R1.
So they took those learnings and they were like, okay, we can make this even better.
Exactly. They wanted to make it more human-friendly.
Right, because at the end of the day, if we can't understand what the AI is doing, it's not really that helpful.
That's a good point.
Yeah.
So with DeepSeek R1, they incorporated elements of supervised learning alongside the reinforcement learning, but they did it very strategically.
Okay.
They used a small amount of long chain of thought data in the early stages of training,
Okay.
which basically guides the model towards more human-readable reasoning.
So it's a bit of a hybrid approach now, but they're still trying to minimize that reliance on these massive data sets.
Right, exactly.
Yeah.
It's all about finding that sweet spot between performance and readability.
Right. Because you want the best of both worlds. You want it to be smart, but you also want it to be understandable.
Absolutely. And another interesting thing they did was they actually used DeepSeek V3, one of the earlier models, to judge some of DeepSeek R1's outputs during training.
Oh, wow. So it's like AI evaluating AI.
Exactly. It's like a form of internal quality control.
That's fascinating. So it's not just about learning from data, it's also about learning from other AI.
Right. And they found that this really helped to improve the overall quality of DeepSeek R1's reasoning.
And they also made sure to train DeepSeek R1 on a wide variety of different prompts, right?
They did, emphasizing helpfulness and harmlessness in its responses.
Okay, so building in those ethical considerations from the start.
Right. It's not just about making AI intelligent, it's about making sure it's aligned with human values.
Absolutely. And how did DeepSeek R1 measure up in terms of performance?
Well, it did very well. It excelled on various benchmarks, showing strength across multiple domains.
Okay, that's good to hear.
But they were also very transparent about areas where it still lags behind.
Right.
One example is software engineering tasks. It's not quite there yet.
Okay, so still room for improvement.
Always,
Yeah.
but overall the results were very encouraging.
Now, all this progress with DeepSeek R1, it begs the question, can smaller models benefit from what it has learned?
That's a great question.
Can we make this level of reasoning power more accessible?
Right, because not everyone has access to the resources needed to train these giant models.
Exactly, and that's where the idea of distillation comes in, right?
Yes. Distillation is basically the process of transferring knowledge from a larger, more complex model to a smaller one.
So it's kind of like an apprenticeship.
Yeah, exactly, like a master craftsman passing on their skills to an apprentice.
Okay, I like that analogy. So instead of starting from scratch, the smaller model gets a head start by learning from the best practices of a larger one.
Precisely, and DeepSeek was actually able to distill a 7 billion parameter model from DeepSeek R1.
Wow.
And get this, it actually outperformed models like GPT-4o0513.
That is really significant. So distillation seems like a viable path to making advanced reasoning capabilities more efficient and more accessible.
It really does, and I think it's an area where we're going to see a lot more research in the coming years.
Now I'm curious, couldn't they achieve the same result just by scaling up the reinforcement learning process on smaller models?
You mean without going through the distillation process?
Yeah, exactly. Like, why not just train a smaller model from scratch using reinforcement learning?
That's a great question, and it's something that DeepSeek actually investigated.
Oh, okay.
They compared a distilled 32 billion parameter model to one of the same size that was trained solely with reinforcement learning.
Okay. And what do they find?
Well, the results were pretty clear. The distilled model consistently outperformed the RL-only model.
Interesting. So at least for now, distillation seems to be the most efficient path to getting these smaller models to perform at a high level.
It does. But, as we push the boundaries of intelligence even further, who knows what the future holds,
Right.
we might need a combination of large models and advanced RL techniques to really unlock the full potential of LLMs.
Yeah, it's an exciting time to be following this field. There's so much happening so quickly. Now, before we move on, I'm curious about the paths not taken.
Oh, you mean the things that didn't work?
Yeah, exactly. The paper mentions some unsuccessful attempts along the way, which I think are just as valuable to understand.
Oh, absolutely. I mean, you learn just as much from your failures as you do from your successes.
Exactly. So what were some of the things that DeepSeek tried that didn't quite pan out?
Well, one approach they tried was using something called process reward models, or PRMs for short. And these are designed to guide the model towards better problem-solving approaches. But they found it really difficult to define those reasoning steps in a way that worked at scale. It was like trying to micromanage the learning process.
Right, trying to tell the AI exactly how to think instead of letting it figure it out on its own.
Exactly. And that's kind of counter to the whole idea of reinforcement learning.
Okay, so what else didn't work?
Well, they also experimented with Monte Carlo tree search, or MCTS,
Okay.
which is an algorithm that was inspired by breakthroughs in game-playing AI, like AlphaGo.
Yes, the AI that mastered Go.
Exactly. And they tried to adapt MCTS to language generation, but the search space was just too vast.
Yeah, language is a lot more complex than a game of Go.
Right? There are so many more possibilities to explore, and it just proved to be computationally impractical.
Okay, so even though these approaches weren't ultimately successful, they still provided valuable insights into the challenges of LLM training.
Absolutely. Sometimes you have to figure out what doesn't work before you can figure out what does.
All right, so now let's look ahead. What's next for DeepSeek R1? Where do they go from here?
Well, they're certainly not resting on their laurels.
Good.
They're committed to continuous improvement, and they're already working on addressing some of the limitations of DeepSeek R1.
Like what?
Well, for example, they're working on improving its general capability,
Okay.
particularly for tasks involving things like multi-turn conversations and complex role-playing.
So making it even more versatile and adaptable.
Exactly. And they're also working on making it less sensitive to how prompts are phrased.
Right. Because right now you have to be very careful about how you word your prompts to get the desired response.
Yeah. And of course, they're still working on improving its performance on those software engineering tasks.
So they're really aiming for a well-rounded LLM that excels in both reasoning and general capability.
Exactly. They want to create an AI that can not only solve complex problems, but can also interact with the world in a natural and intuitive way.
Well, this is all very exciting stuff. I'm really looking forward to seeing what DeepSeek comes up with next.
Me too. It's an exciting time to be working in AI, that's for sure.
Absolutely. Welcome back. We just finished looking at how DeepSeek R1 learns, but now I want to talk about the bigger picture.
Yeah.
What are the implications of this work?
Right.
One thing that people always bring up when we talk about AI is jobs.
Mm-hmm.
Are robots going to take our jobs? Are we all going to be out of work?
It's a valid concern.
Yeah.
I mean, history shows that new technology often disrupts the job market,
Right.
but it also creates new opportunities.
Right. It's not necessarily a one-to-one replacement.
Exactly. Think about the invention of the automobile.
Okay.
It put a lot of carriage drivers out of business,
Yeah.
but it also created this whole new industry around manufacturing and repair and infrastructure.
So it's more like a shifting landscape.
Right, exactly. And I think the key is to focus on the skills that complement AI rather than trying to compete with it.
So things that AI isn't good at.
Right, things like creativity, critical thinking, complex problem-solving, emotional intelligence.
The human stuff.
Exactly, the things that make us human.
So instead of being afraid of AI, we should be thinking about how to leverage its strengths to augment our own.
Exactly. I think that's the key.
Okay, so imagine a world where AI handles all the routine tasks.
Right, boring stuff.
Yeah, and that frees up humans to focus on higher level thinking, innovation, interpersonal interactions.
That's a pretty compelling vision.
It is. It sounds like AI could actually lead to more meaningful work for humans.
I think it has the potential to.
Okay, but what about misuse?
Right.
We've all seen those sci-fi movies where the AI turns evil and takes over the world.
Yeah, the Terminator scenario.
Exactly. So how do we prevent that from happening in the real world?
Well, that's why responsible AI development is so crucial.
Yeah.
It's not just about making AI powerful. It's about making sure that it's safe and ethical and aligned with human values.
Right, building in those safeguards from the start.
Exactly. And DeepSeek is actually taking this very seriously.
Okay, good.
Their reinforcement learning for all scenarios approach that we talked about earlier, that's all about instilling those values of helpfulness and harmlessness into the model.
So it's not just teaching it to be smart, it's teaching it to be good.
Right. You could say that.
Okay, but let's say hypothetically that an AI does cause harm, despite all these precautions.
Okay.
Who's responsible?
That's a tough question.
Right.
It's something that we as a society need to figure out.
Yeah.
Who's liable if a self-driving car gets into an accident?
Right.
Is it the manufacturer, the programmer, the owner?
It's a really tricky question.
It is, and it's one that we're going to have to grapple with more and more as AI becomes more integrated into our lives.
It seems like this is an area where we need clearer legal frameworks and ethical guidelines.
I think so, yeah.
Because the technology is moving so fast that the laws and the ethics are having trouble keeping up.
That's right. It's a constant game of catch-up.
Okay, so before we move on, I want to ask you a more personal question. What do you think is the most exciting potential benefit of AI?
Oh, wow, that's a big one.
And what do you think is the biggest risk that we need to guard against?
Okay. I think the most exciting potential benefit of AI is its ability to solve problems that have long stumped humanity.
Okay, like what?
Like curing diseases, combating climate change, exploring the universe in ways that we never thought possible.
Yeah, those are big ones.
They are, and I think AI has the potential to help us make significant progress in all of those areas.
That's really inspiring. Okay, but what about the risks?
Well, I think the biggest risk is that we become overly reliant on AI.
Okay.
We outsource our critical thinking skills to machines.
We become lazy and complacent.
Yeah, exactly.
Yeah.
And then what happens if the AI is wrong or if it's being used for malicious purposes?
Right. We need to make sure that AI remains a tool that augments human intelligence,
I agree.
not replaces it.
Exactly. It's all about finding that balance, that synergy between human and artificial intelligence.
Okay, so it sounds like we have a lot to think about here.
We do.
Both the potential benefits and the potential risks.
Absolutely.
It's an exciting time to be alive, that's for sure, but it's also a time for caution and careful consideration.
I couldn't agree more.
All right, and we're back for the final part of our deep dive into DeepSeek's work on LLMs.
Okay.
So before we wrap things up, I want to make sure we highlight the key takeaways. What makes DeepSeek's research so important?
Well, I think one of the biggest takeaways is that you can achieve some pretty impressive reasoning capabilities in LLMs without needing tons and tons of labeled data.
Right. Their use of reinforcement learning, especially with DeepSeek R10, it shows that we can teach machines to think more like humans.
Yeah, learning from rewards, self-correcting along the way.
And the results are impressive, like they're reaching performance levels comparable to some of the top models out there.
It's true, but it's not just about raw intelligence. They also focus on making these models more user-friendly, which is super important if we're going to use them in the real world.
Yeah, absolutely. And it's refreshing to see that they're also transparent about the challenges. They highlight the areas where DeepSeek R1 still falls short, particularly with things like software engineering tasks.
Yeah, they're not just hyping up their work, they're being honest about the limitations.
Exactly. And that honesty is important, especially in a field that can be prone to hype.
I agree completely.
Mm-hmm.
And speaking of improvements, their work on distillation is really exciting.
Yeah. What are your thoughts on that?
Well, it opens up a whole new world of possibilities.
Yeah.
It means we can bring these advanced reasoning capabilities to smaller, more efficient models.
Which is huge, especially for folks who don't have access to the massive computing resources needed to train those giant models.
Exactly. It makes this technology more accessible, which could lead to a whole wave of innovation.
And we can't forget about those aha moments. Those were pretty amazing.
I know, right? See, in an AI model actually reevaluating its approach, like in the middle of a problem, that's just mind-blowing.
It really is. It's like a glimpse into the future of machine learning.
It makes you wonder what else these models are capable of.
Right? It challenges our assumptions about what AI can do.
I think we're just scratching the surface of what's possible.
So now that we know that LLMs can learn to think more effectively, what do you see as the most promising applications for this technology?
Oh, wow, that's a tough one. There are so many possibilities.
I know, right? But if you had to pick a few, what would they be?
Well, I'm really interested in how this could revolutionize fields like scientific research, medicine, and education.
Okay, I can see that.
Imagine AI collaborating with scientists to speed up drug discovery or personalizing learning experiences for students.
Or even helping us tackle some of the world's biggest challenges like climate change.
Exactly. The potential is huge.
It is. But of course, there are also potential downsides. What are some of the things we need to be careful about?
Well, one thing that worries me is that we become overly reliant on AI. We start outsourcing our critical thinking skills to machines.
Right.
And then what happens if the AI is wrong or if it's being used for malicious purposes?
That's a scary thought.
It is. We need to make sure that AI remains a tool that augments human intelligence, not replaces it.
Right. It's all about finding that balance, that synergy between human and artificial intelligence.
Absolutely. And we also need to be very careful about bias.
Yeah.
These models are only as good as the data they're trained on.
So if the data is biased, the AI will be biased too.
Exactly. And that could have some serious consequences.
So it all comes down to responsible development and deployment.
That's right. We need to make sure that AI is used for good.
Well said. Well, we've covered a lot of ground in this deep dive. We talked about DeepSeek's work on LLMs, the potential benefits, the potential risks, and everything in between.
It's been a fascinating conversation.
It really has, and I hope our listeners have found it informative and thought-provoking.
Me too.
So as we wrap up here, I want to leave our listeners with one final thought. Now that, LLMs can learn to think more effectively, what tasks become possible that weren't before? What problems could we solve? What could we create? What could we explore that was once beyond our reach?
Those are great questions.
The future of AI is unfolding before us, and it's up to all of us to imagine and shape what it will become.
Well said.
Thanks for joining us on this deep dive, and keep those minds curious.